So I want you to open up your notes to look for the first lesson in the radical and exponents. And I just want to go over fractions before we get into this chapter because we're going to be using them a lot. So first thing I want to review is how to review fractions. So let's take the first one, 28 over 126. We've got to reduce this to smaller numbers without changing. Now I'm going to use the ladder method just to make it easier. So I'm going to put both numbers. I always put the first one, the top one on first, the bottom one second. So any number that goes into this, I can see 2 goes into it. So I divide both by 2. Now 2 doesn't go into this one, so I'm going to go up. Always try and do prime numbers. 3 does not go into 14. 7 goes into 14. 7 goes into this, so I'm going to remove 7 from both. 14 divided by 7 is 2. 63 divided by 7 is 9. And we get to a point where nothing other than 1 goes into 2 and 9. That is my fraction. 28 over 126 reduces to 2 over 9. So the ladder method just takes out any GCF that we can. We keep going until we're left with nothing that can be removed. So now let's try this one here, 242 over 55. Now it's bigger numbers, so you probably won't be able to do this in your head. So right away I go up my list of primes. 2 does not go into 55. 3 does not go into 55. If you're not sure about this, use your calculator. If you get a decimal, go on to the next one. Next prime is 5. Definitely doesn't go into 242. Again, use your calculator if you're not sure. And 55 divided by 7 doesn't work. Is keep going up. 11. 11 goes into 5. 11 goes into 242. So check your primes. 242 divided by 11 is 22. 55, there we go. Now 5 is a prime number. It does not go in here, so I'm done. My new fraction. And just to double check, my original one had the bigger number on top. This one has the bigger number on top. It's always this one over that one if you followed that pattern. So try these ones on your own. See how far you can get. See if you get the reduced fraction. Check your answer once you're done. So pause the video now. Okay, so hopefully you tried it. 76 and 6, 2 goes into both. Now 3 is a prime number, so does 3 go into 38? It doesn't. So my reduced fraction, 38 over 3. Bigger number on top for both fractions, so I know I've got it in the right order. So this one here, 2 does not go into 7, 3 doesn't, 5 doesn't, 7 goes into 7, but it doesn't go into 24. So I'm pretty much stuck. I can't reduce it. 24 over 7 is the reduced fraction. We can't do anything. And adding fractions. Now, adding fractions is pretty straightforward if the denominators are the same, common denominators. If it's the same, we're going to add the tops. 1 plus 8 is 9. But the bottom stays the same. We do not change it. If we have this one, we can't do anything like this because it has different denominators. So what I need to do is to get common denominators, I've got to find a lowest common multiple. So 4, 8, 12. Twelve is the lowest common multiple. And you can just multiply 3 times this. And I have to do it top and bottom. I'm not allowed to multiply just the top or just the bottom. This one needs to go to 12, so I have to multiply by 4. So I'm going to get 3 over 12 and 20 over 12. And so we end up with 23 over 12. Now, one thing you have to do with all adding, subtracting, all fractions is ask, can I reduce it when I'm finished? 23 over 12, nothing goes into both of them. 23 is prime, and it doesn't go into 12. But our first question, 9 divided by 3, I can divide both by 3, and it just, the 1 becomes invisible. 9 divided by 3 is 3. Subtracting fractions has the exact same rules as adding. So what we're going to do, common denominators, so I just subtract the tops. The bottom stays the same. Now again, we finish, we want to reduce if possible. Both of these are divisible by 2. Becomes 3 halves instead of 6/4. Same number, just reduced form. This one, this messes people up because there's no fraction over here. Remember, there's an invisible 1 on bottom, and these are actually easier because it's very easy to get common denominators. To make this a 3, multiply top and bottom by 3. 5 times 3 is 15. 3 and 13 are both prime. There's nothing I can do to reduce it. So multiplication is completely opposite. We're going to multiply the tops and multiply the bottoms. Before we left the bottoms the same, but now we actually multiply the bottoms. So 8 on top, 3 times 5 is 15. We always want to reduce. Nothing goes into 8 and 15, so in this case, we're done. It might be easier to look at the original and see if there's anything top and bottom that can be reduced. And a key thing is never reduce side to side, top to top, or bottom to bottom. It always has to be something on top, something on bottom. So this one here, I like to reduce first, and I can see 4 and 8. I'm going to divide both of them by 4. I get 1 and 2 instead. I've already done my reduction before I even start. I also see 6 and 9 are divisible by 3. So if I divide by 3, I get new numbers. So on top, I'm left with 2 and 1. 2 times 1 is 2. 2 times 3, oh, actually, I can reduce even more. 2 over 6 equals 1 over 3. So always check your final answer. Make sure you can reduce as far as you can. And the final one, division. So the one trick with division is anytime we divide, we're basically going to switch it to multiplication. So the first one stays the same, 3/4 times. But when we switch it, we take the reciprocal of the second fraction. We flip the second fraction. So instead of dividing by 2/3, we're going to multiply by 3 over 2. We can see there's nothing that we can reduce, so 3 times 3 is 9, 4 times 2 is 8. So division, flip the second fraction, and then do the same thing as multiplication. So this one, 8 goes on top, 5 on bottom, and I can see that I'm going to reduce these ones. 8 over 2, divide both by 2. 1 times 4, 1 times 5. If you don't reduce it here, make sure you reduce when you're over in the final answer.